Hello students, welcome back to Byju's classes. My name is Namrata and we will discuss remaining questions of JEE Main 2021 paper Day 1 Shift 2. So let's start. Next we have a very basic question from inverse trigonometry. If you look at this question, actually how to tackle these type of questions is we need to convert this question into normal trigonometry question. Yes, I'll tell you how. So I can see that this is tan of 1 by 4 sine inverse root 63 by 8. Isn't it? Sine inverse root 63 by 8. Let us assume this is the angle theta. Alright, if this is theta, then we need to figure out the value of tan theta by 4. Right? First of all, we need to define theta. I know solving is very easy, but here let's first define the theta. Very important step. Since sine inverse of some positive angle, which is lying between 0 and 1, is theta. So theta over here will belong to first or second quadrant. You all know that in first and second quadrant, sine theta is positive and lying between, of course, 0 and 1. So this is belonging to 0 to pi. Right, and we are looking for theta by 4. If I talk about theta by 2 or theta by 4, very interestingly, theta by 2 will belong to 0 to pi by 2 and theta by 4 will belong to 0 to pi by 4. That means these two for sure will lie in first quadrant. Right, if theta belongs to first or second quadrant, theta by 2, theta by 4 both will lie in first quadrant. Moreover, precisely theta by 4 will lie between 0 to pi by 4. Alright, so on this note, let's start this question. So here we have theta is equals to sine inverse root 63 by 8. That means sine theta equals to root 63 by 8. Isn't it? Okay. And we need to figure out the value of tan theta by 4. Now the whole question, mind it, very interesting. This is sine theta. And we need to figure out value of tan theta by 4. Where is the inverse trigonometry over here? Nowhere. We have converted the question nicely in normal trigonometry question. Right? Okay. Now how to solve this? We need few relations, few formulas of multiple and submultiple angles. What are these formulas? So first of all, tan theta by 4. Actually, I can reach tan theta by 4 once I know cos theta by 2. Right? You see. Cos theta by 2 is nothing but 1 minus tan square theta by 4 whole upon 1 plus tan square theta by 4. So what I need right now is cos theta by 2 value. Right? Now cos theta by 2. I have sin theta. I need cos theta by 2. If I know cos theta, I can easily calculate cos theta by 2 by this formula. Cos theta is equals to 2 cos square theta by 2 minus 1. Right, but right now I am having sin theta. So now you can connect the dots. I have sin theta. I can calculate the value of cos theta. If I have cos theta, I can calculate the value of cos theta by 2. If I have cos theta by 2, I can calculate the value of tan theta by 4. Alright, just a formula game. Let's start. So sin theta, let's make a right angle triangle. So here we have perpendicular upon hypotenuse. So this is 8. This is theta, this is square root of 63, this would be 1 if you apply Pythagoras theorem. So cos theta you get over here is 1 by 8, which is equals to 2 cos square theta minus 1. Theta by 2 minus 1. Right? 2 cos square theta by 2 minus 1. So here from this what do you get? You get the value of cos square theta by 2, which is nothing but 9 by 16. Yes. Cos square theta by 2 is nothing but 9 by 16. That means the value of cos theta by 2 is plus minus 3 by 4. Right? And we have already discussed over here that theta belongs to 0 to pi. Right? This implies theta by 2 will belong to 0 to pi by 2. That is in first quadrant. Theta by 2 belongs to first quadrant. That means the value of cos theta by 2 will be positive. So that means we need to reject the negative sign. So cos theta by 2 is 3 by 4. What are we waiting for? We just need to put the value over here. 3 by 4 is cos theta by 2. That is equals to 1 minus tan square theta by 4 whole upon 1 plus tan square theta by 4. Let's just cross multiply. If I do that, what do I get? So 4 minus 4 tan square theta by 4 equal to 3 plus 3 tan square theta by 4. Let's just shift. 1 equals to 7 tan square theta by 4. tan theta by 4 is plus minus 1 by root 7. Since you know now theta by 4, theta by 2 belongs to first quadrant, theta by 4 would be a positive. Tan theta by 4 would be a positive number, right? Because this is also belonging to first quadrant, even it is belonging to 0 to pi by 4. So the value will be positive. I am rejecting negative value, and tan theta by 4 will be equal to 1 by root 7. Very easy question, isn't it? In this question, the equation of tangent to some curve is given to us, and a point of contact is also given to us. What is unknown over here is a curve at which the tangent is drawn, right? So let's check option by option. Let's talk about option A. First of all, if this is the tangent to this particular curve at this point should satisfy this curve. Yes, the very first prerequisite is that point should lie on that particular curve. Then only we can say that we can draw a tangent on that particular point, isn't it? So let's check whether this satisfies the curve or not. So we have 3 root 3 by 2 whole square, and then we have 9 1 by 2 whole square, and this should be equal to 9. Both LHS and RHS should be equal. So here we have 27 by 2, 27 by 4. Plus we have 9 by 4, right? This should be equal to 9. 27 plus 9 is 36. 36 by 4 is 9. 9 equals to 9. That means this point is definitely lying on this curve. Alright. The next task is to calculate the equation of tangent at this particular point. How to do that? We have point of contact. We have equation of curve. So by t equals to 0, we can write the equation of tangent, right? How to write it? So here x square will be replaced by x1, where x1 comma y1 is a point of contact, which is this particular thing in this case, right? So here t equals to 0, back to t equals to 0, x square will be replaced by x1, y square will be replaced by y1, rest over here will be same. Let's write the equation. x1 would be what? 3 root 3 by 2. 9y, y1 is what? 1 by 2, that is equals to 9, right? This 3 can be get cancelled out. So this is it. This is our equation. Root 3x plus 3y equal to 6, right? And we need to check whether these two equations are same or not. How to check? For this particular equation, I'll divide the whole equation by root 3. Let's do that. If I do that, that would be what? X plus root 3y equals to 2 root 3. Exactly same. Exactly matching with this one, right? So option A is clear-cut true. This saved a lot of time of ours because we don't need to check B, C and D. Option A is true, right? Got it? The question is from the chapter Mathematical Reasoning, which says for two statements P and Q, we have two compound statements. And we need to figure out which of the following options is correct. A option says A is tautology, B is not. And option B says both are not tautologies. Option C says A and B both are tautologies. And option D says B is tautology but not A. Okay, let's begin. So what is the method? We just need to form a truth table. We need to check whether all the entries are true or not. If it is true, then tautology. If not, then not a tautology. Let's begin. So let's first draw a truth table. P and Q we have already, right? T, T, F, F and then T, F, T, F. That's how we plot the P and Q, right? Now next thing is we need to figure out not Q, right? Let's do that. Not Q means here it will be false, then true, then false, then true, just like this. Okay, what is next? In here we need to calculate truth table for if P then Q. What is if P then Q? Actually, if P then Q is always true unless P is true and Q is false. P is true and Q is false. So here I'll write false. Elsewhere I'll write true, right? So true, then we have false, then we have true, true. Cool. What about this? The whole this. Negation of Q and if P then Q, right? So that means we need to figure out and between and between these two quantities, isn't it? These two compound statements. So here we have and. Okay, how to find and? If both are true, then I'll write true. Okay, so this is true, rest else is false in this case, right? So false, 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 and then last we have true. Okay, cool, this is sorted. Now what I need is negation of P. So negation of P will be calculated by this. So that would have false, false, true, true. Right? Now last we have everything. We just need to take if this, then negation of P. So if this, then negation of P. Let's do that. Okay. We have already discussed this is false if this is true and this is false. So which I am not able to see any combination in which this has true and this has false, right? That means everything over here would be true and hence this is a tautology. Let's talk about the next compound statement, which is this. So we have PQ with us. Let's calculate P or Q. How does OR operation work? OR operation is false when both are false. I'll write false over here and rest I'll write true. True, 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 false. That's all. Right, let's talk about negation P. So that would be what? Negation P would be false, false, true, true. Right? And we need to take AND between these two. How does AND operation work? So I need both true to write it true over here. Elsewhere it is false. So if one is false, I'll write false, then false, then false. So we have AND between these two. So we have FF, TF. Right? Last we have to take if of this statement, then this. What do we know about if and then? So for this combination, we have false. Yes. If first one is true, second one is false, then we'll write false over here. So let's find out the combination, such combination, right? We are looking for this. So this is F and this is what? T. So I'll write T over here. Right? Okay. This is F again. I'll write T over here. Cool. This is T, of course T, and FF, of course T. Alright. So there is actually no such combination in which this is T and this one is F. See, so nothing is false over here. This is also a tautology. A and B both are tautologies. Option C is absolutely right answer. The next question is from the section calculus. In fact, we have two different topics involved. First one is differential equation and second one is definite integrals. Very, very trendy things. Hybrid question of two topics, right? So in this, y equals to fx is a curve which is passing through 1, 2 and satisfy this differential equation. We need to figure out the value of b, and one more thing, the definite integral of f of x from 1 to 2 is 62 by 5. Okay, so let's start with the differential equation. Let's understand what form of differential equation is this, what is the type. So I can clearly see if I divide this by x, what do I get? Dy by dx equals to x, okay, plus y by x equals to bx cube. Are you able to recognize this is linear differential equation? Dy by dx plus py equals to q, where p and q both are function of x. So here p is 1 by x and q is bx cube, of course, right? Okay, how to solve it? Very, very straightforward method. This is the method. We need to calculate integrating factor first, and the solution would be y multiply integrating factor, and on the right hand side we have integral of q with respect to dx. Of course, integrating factor multiply q with respect to dx. Right? This is the solution set. What is integrating factor? Integrating factor is nothing but e raised to power integration of p dx. So in here p is 1 by x, right? So e raised to power 1 by x dx. That means e raised to power ln x, that is equals to x. Integrating factor is what? X. Okay, let's just put the value of integrating factor in this. What do I get? I get y multiply x equal to integration of x multiply bx cube dx. Right? So what I'll get is yx equals to bx raised to power 5 by 5 plus constant c, right? And we all know that y is nothing but f of x, which is passing through point 1, 2, right? That means y equals to f of x, right? So when x is equals to 1, y equals to 2. In this, let's just put the value to get the value of c, constant. Okay, so 2 multiply 1, that is equals to b by 5 plus c. So what we are getting over here is first equation. Yes, the first equation, b by 5 plus c is equals to 2 in terms of b and c, right? What is the another thing given to us? Another thing is given to us in terms of definite integral, which is integration of fx with respect to dx from 1 to 2 is nothing but 62 by 5. Let's just solve this. Let's just put the value of fx over here because we've already got this. Let's just do that. Okay, so now the value of fx we've already sorted, bx raised to power 4 by 5 plus c by x, right? Because we've already figured out yx is equals to bx raised to power 5 by 5 plus c, and y is what? F of x. So here y would be bx raised to power 4 by 5 plus c by x. So fx is replaced by this function, right? Let's tackle this now. Let's just integrate it. So if I integrate it, actually what do I get? I get bx raised to power 5 by 25 c ln x, upper and lower limit 1 and 2, right? So, and this would be what? 62 by 5. No need of constant of integration because this is definite integrals, right? Let's just put upper limit, subtract it, lower limit, right? If you do that, what would you get? You get this, right? The moment you put 2 raised to power 2 in place of x, you get 2 raised to power 5, 32 plus c ln 2 minus of the whole thing with x equals to 1, which is nothing but this, right? When x is 1, ln 1 is 0. So no involvement of c in later terms, right? So this is it. We have two equations. Can you see? We have two equations involving b and c. We need to just solve these two equations. Let's do that. So basically this equation, if I talk about, this is 31b by 25 plus c ln 2, that is equals to 62 by 5. In here, if I multiply 31, so what do I get? I get 62, that is equal to 31b by 5 plus 31c. Let's just divide everything by 5 as well. So we have 5, we have 25, we have 5. This is the equation. If I subtract this equation by this, what do I get? These two will get cancelled out, right? These two will also get cancelled out. We are actually left with some constant multiply c, that is equals to 0. That means c is clear cut 0. Yes, c is 0. The moment I say c is 0, I get b equals to 10. So from equation 1 and 2, you can easily calculate b 10 and c 0. So we need to tell the value of b, not c. So option D, the value of b is 10. Got it? As expected, we have a question from area under curve as well, which says we need to figure out the area of the region where y is greater than or equal to 5x square but less than or equal to 2x square plus 9. We need to plot this particular region and find out the area. So let's begin. Okay, all right. In this Cartesian plane, we'll be plotting this area. Okay, so y less than or equal to 2x square plus 9, that means we need to actually plot these two curves, y equals to 2x square plus 9 and y equals to 5x square. You all know that y equals to 5x square is upward facing parabola which is touching origin. Yes, origin like this. 2 repeated roots at origin. This is the graph of this 5x square, right? And what about 2x square plus 9? 2x square plus 9, how do we plot it? So we need to actually figure out intersection point of these two curves. Let's equate 2x square plus 9 equals to 5x square. We have 9 equals to 3x square and we have x square equal to 3. If x square is 3, then x would be equal to what? Plus minus root 3. So here the point of intersection I'll get over here, right? And see, both the parabolas are symmetric about y-axis, and moreover, if I talk about the value at x equals to 0, the moment I put x equals to 0, I get 9. Yes, x equals to 0, y equals to 9, right? We need to plot this curve at this is minus root 3, this is plus root 3, right? Let's plot the curve. Let's complete the curve. These are the two curves, right? And of course minus root 3 plus root 3 already calculated. And now let's focus on the area. Which area this question is talking about? Y is less than or equal to this. That means below this curve and above this curve, right? Just like this. This is the shaded area. This is the area I'm interested in. And of course one more thing, this area is symmetrical about y-axis. Okay, so if I'm able to figure out this area and if I multiply 2 in this, what do I get? The overall area, the required area. So let's figure out the required area by definite integral method, area under curve. So required area will be equal to twice of this particular area. So 0 to root 3 we need to integrate, right? And what would be the expression? So upper curve minus lower curve. What is upper curve? This 2x square plus 9 minus lower curve, which is 5x square with respect to dx. This we need to find out. This is the final answer. Okay, just normal definite integral. So this would be what? 9 minus 3x square, right? With respect to, of course, dx. So this, if I integrate it, what do I get? Twice of 9x minus 3x cube by 3. So that would be what? X cube. And 0 and root 3 I'm having. Let's put the upper limit and then minus lower limit. So we have 9 root 3 minus 3 root 3 minus, okay, of course it is 0. Alright, so 9 minus 3 is what? 6. 6 root 3 multiplied 2 will give us 12 root 3 as our final answer. Extremely easy question if you know how to plot the graph, how to select the area and upper curve minus lower curve, finding the points, right? Option B is the right answer. Got it? In here we have fx, which is a differentiable function defined on 0 close to 2 close, such that f dash x is equal to f dash 2 minus x, where x belongs to 0 to 2. Furthermore, here given as f of 0 is 1, f of 2 is e square, then we need to figure out the value of this integration, definite integration of fx from 0 to 2. Alright, so let's begin. Just few manipulations and few thoughtful things to apply in this question and you'll get your answer. Few definite integral properties as well, right? Okay, so I am actually interested in f of x, isn't it? So that I'll be able to integrate it. So why not integrate it both the sides? Let's integrate both the sides so that I can get rid of f dash x. Very first thought. So on integrating this, what do we get? So integration of f dash x dx, that is equals to f dash 2 minus x, integration of this, right? Now this integration would be what? F of x. This would be what? F of 2 minus x with a negative sign. Let's not forget. And of course, it's indefinite integration plus c, constant of integration, right? So I get this. I'm getting this, right? Okay. But what about this c? I want to get rid of the c and we have information over here as well. The initial condition, right? So the moment I put x equal to 0 in this, what do I get? The moment I put x equals to 0, I actually get f of 0, that is equals to minus f of 2 minus 0 plus c, right? We have put x equals to 0, so I am getting f of 0 equals to minus f of 2 plus c. Let's put the values. We have f of 0, we have f of 2. So what do I get? We have 1 is equals to minus e square plus c. That means c is 1 plus e square. At least I've got rid of this. So now this particular equation, this equation will become what? Fx plus f of 2 minus x is a constant 1 plus e square. And now what we are looking for is this value, right? But actually I don't have fx. What I have is f of x plus f of 2 minus x. Now listen to me carefully. Extremely important thing happening over here is, see, there is some reason why there is 0 and 2 involved. If I apply a property of determinant, this I will be what? Let me show you the property. So if 0 to a f of x dx is there, this is the integral, then this integral would be equal to 0 to a again, but f of 0 plus a. minus x dx. Yes, this is the definite integral property. The moment I apply this, I can create f of 2 minus x, right? So 0 to 2 f of 2 minus x dx. These two are one and same thing by property of definite integrals, which I have just discussed with you. Now what to do? Since I have summation of these two with me, so why not add these two? If I add these two, what do I get? I'm adding 1 and 2. So 2i would be equal to integral 0 to 2, and in this we have f of x plus f of 2 minus x, yes, with respect to dx. And I'll be actually replacing, this is time, we need to replace this with 1 plus e square, and we have dx. 1 plus e square. Integral of any constant with respect to dx is that constant multiply x. So we have, if you integrate this, we have 2i is equals to twice of, by putting upper lower limit, we have this. 2i is equals to 2, 1 plus e square, 2 gone, and this integral which we are looking for is nothing but 1 plus e square, matching with sitting in option A. Alright. So now we have a question from section 2, numerical answer type question. These are 10 questions. We need to only attempt 5 out of them. This is the best part. So we have a choice. So we need to select the questions smartly. Okay, let's start. Let's see. Okay, so we have to figure out the number of real roots of this equation. Okay, so this question is a normal quadratic involving modulus question, right? So the concept wise, this question is extremely easy, but I can see the involvement of this 27 by 4 makes it look that it might take a lot of time to solve this question. If I were a student, I wouldn't have chosen this. I would have ignored this and I would have done the next question, right? Look for the next question. But then we are discussing each and every question in this section. So let's start doing this. So we have this, right? The moment you see modulus, what do you see? That you need to take two cases. First, x is greater than or equal to 5. When x is greater than or equal to 5, this will get opened with, modulus will get opened with a positive sign. Right, now we just need to solve it. Let's do that. So x square plus 2x plus 1 plus x minus 5 equals to 27 by, okay, this is 4. Right, so you have x square plus 3x minus 4 equals to 27 by 4. See, I told you, now you need to do the calculations. If you solve minus 4 minus 27 by 4, you'll get minus 43 by 4. You need to solve this quadratic. Let's start with quadratic formula. Let's just first take LCM. So that would be what? 4x square plus 12x minus 43 equals to 0. Now let's apply quadratic formula. So minus 12 plus minus under root of 12 square minus 4 multiply minus 43 whole upon 2 multiply 4 minus b plus minus under root of b square minus 4ac by 2a. Right, you'll get this. You can solve this, you can do the calculation. Let's now solve this. So this would be what? Root 832. Let's write 832 in this step. And root 832. Actually, if I talk about 30 square, I have 900. Right? And if I talk about 29 square, that would be greater than 832. Right? And if I talk about 28 square, you figure out the values. So this 28 square should be slightly less than 832. So now you can see that 832, square root of 832 is lying between 28 and 29. Approximately the value would be 28.8. I'm looking for approximate value because in here I'm looking for the roots which are greater than 5. If you solve this, what would you get? So you get, okay, so this is what? 2 and this would be 3, right? And this is something 7.2. So minus 3 plus minus 7.2 by 2. Two values, right? Let's separate plus and minus sign together. So now we have, actually, you realize one thing, this one is negative. I'm looking for x greater than or equals to 5, rejected. Right? And this one is 7 minus 3. That means this is 4 point something by 2. This is less than 5. Right? So in here, for this particular case, I'm not having any solution. Let's talk about the case where x is less than 5, just like this. When x is less than 5, this modulus will get opened with a negative sign. So this is plus 5 minus x equals to 27 by 4. Let's expand. Let's solve it. X square plus 2x plus 1 plus 5 minus x equals to 27. Okay, this is by 4. Right? See, I told you I am not interested in doing this question because this involves, in mains paper of course, because this involves a small calculations which can lead to some error, right? Okay, x square plus x plus 6, that is equal to 27 by 4. Is it right? Yes. X square plus x plus 6, that is equals to 27 by 4. Okay, if you solve these two, what would you get? The quadratic equation is this. Now again we will apply. Okay, let's first take LCM. So 4x square plus 4x minus 3 equals to 0. This is the quadratic equation, right? Let's just apply quadratic formula. Minus 4 plus minus square root of 16 plus 4 4s are 16, 16 3s are 48 by 8. Just like this. If you solve this, what would you get? So this is 16 plus 48, that is 64. Square root of 64 is 8. So minus 4 plus minus 8 by 8. So we have got two roots. So both the roots actually are, if I take plus sign, I get 1 by 2. If I take minus sign, I get minus 3 by 2. So these are the two roots. I am looking for x less than 5. In fact, both the solutions are less than 5. Do you realize this? That means overall, first case is giving me no solutions, second case giving me two solutions. So overall, two solutions. So number of real roots is nothing but 2. Alright. Next question is from the chapter Permutation and Combination, which says we have 10 students which are divided into 3 groups A, B and C, such that each group has at least one student. Okay, and group C has at most 3 students. Then we need to figure out total number of possibilities of forming such groups. Okay, so two conditions. First one is each group has minimum 1 student and group C has at most 3 students. Let's talk about group C. Actually, group C will have exactly 3 cases. Either it has 1 student, because it cannot have 0 students, right? At least 1 in each group I have to set, right? So group C will have either 1 or 2 or 3 students, that's all. So these are the 3 cases we'll be working on. Let's discuss case by case. 10 students should be divided into 3 groups A, B, C, right? And the condition is each group has at least 1 student and group C has at most 3 students. So the cases, let's discuss. So case 1. Case 1 says that we have 1 student in C and rest students will be there in A and B. That means 9 students will be distributed in A and B. Similarly, case 2 will have 2 students in group C and 8 students remaining, of course, 8 students in A and B combined. Similarly, case 3 will have 3 students in group C and remaining 7 will be in A and B. These are the 3 cases we'll be working on, and since either case 1 or case 2 or case 3 will be adding these 3, right? We'll be adding the possibilities of these 3 cases. Let's begin. Group C has 1 student, right? I have 10 students. I want 1 student in group C. That can be done by 10C1 ways, right? I need to just select 1 student out of 10 and put it in group C. Group C is sorted. Let's talk about A plus B. Now, what I need to do is 9 students, and that can be either in A or in B, right? So that means each student out of 9 will have 2 choices, either to go in group A or to go in group B, right? Each student out of 9. So student number 1, how many choices? 2 choices. Student number 2, how many choices? 2 choices. Student number 3, 2 choices, and so on up to student number 9, 2 choices. So 2 raised to power 9. 2 raised to power 9 ways I can distribute 9 students in A and B. But one more condition I am forgetting over here. No, I am not forgetting. We need to tackle this condition that each group has at least 1 student. So there will be one case in which all the students are going in group A. That is, I don't want. There is one case. And Of course, there will be another case in which all the students, all the 9 students I'm talking about, are going in group B. So actually we need to subtract these 2 cases out of 2 raised to power 9 total cases, right? So now let's just write everything nicely. Number of ways of dividing remaining 9 students into groups A and B would be 2 raised to power 9 minus 2. These 2 cases are those cases where all the 9 students are going either in A or in B completely. Okay, so now let's just multiply this and this to get total number of ways of case 1. 10C1 multiply 2 raised to power 9 minus 2. So here we have 10 multiply, we have 512. Okay, so we have actually 510. So 5100. 5100 is the answer of case number 1. So total ways of case 1 would be denoted by this. Let's talk about case 2 in similar manner. Now you know the drill. Case number 2. So we need 2 students in group C. Right? 2 students. So we need to select 2. That can be done by 10C 2 ways. Right? And then remaining 8 students in A and B both similarly 2 raised to power 8, but 2 cases we need to remove in which where all 8 remaining students are going completely in A, because we have a condition we have to have at least 1 in both A and B. So everyone is going in A, then B will have 0 students, that I don't want, and vice versa, hence subtraction of 2. If you solve it, what would you get? You actually get, this is what, 10 multiply 9 by 2, and this would be what, 256, so 254. If you solve it, what would you get? 11430. Case number 2 has 11430, right? What about case number 3? Now you know the drill. 10C3, right? 10C3 multiply 2 raised to power 7 minus 2. If you are able to crack case 1, case 2 and case 3 are similar. Let's solve it. If you solve it, 15120. Let's add these 3 numbers. If you add it, you get 31,650. 31,650 possible ways. Okay. In this question, it is given that A plus alpha equals to 1. B plus beta equals to 2, and a functional equation involving A alpha and B beta is given to us. Then we need to figure out the value of f of x plus f of 1 by x whole upon x plus 1 by x. Very basic question, a freebie question I would say. 4 marks straight in your pockets. First I'll discuss shortcut, very important shortcut. So can you see over here that A plus alpha equals 1. A plus alpha is 1 and this is A, this is alpha, right? What I want is f of x plus f of 1 by x. The coefficient of both is 1, right? I can achieve if A and alpha both are equal. Let's put A and alpha equal. So you can easily say that half and half is equals to 1. So A would be half, alpha would be half. That would do justice to this. And similarly, I'm talking about x plus 1 by x in the denominator. I want this. So B and beta, if they are equal, I can get both common. So B, beta both are equal. That means B is 1, beta is 1. Just hit and trial, right? Okay. So now let's just put values over here. A is 1 by 2, f of x plus 1 by 2. Alpha is also 1 by 2, right? F of 1 by x. That is equal to B and beta both are 1. That is x plus 1 by x. Right? Now let's just shift this on the right hand side in the denominator and 2 in the numerator. So 2 would be equals to what we are looking for. Do you realize how many seconds this question will take? 10, 15, that's it. Right? So final answer would be what? 2. Very simple question. This is objective approach, hit and trial approach. Anybody can judge it, right? And we have second method, the subjective method. Let's discuss that. Okay. Again, we'll be working around same thing. So what I want is, okay, you know how functional equation works, right? X and 1 by x are involved. In the starting, we have already told you when we were studying that x will be replaced by 1 by x. Very basic things in such questions when we practice at the time of preparation, right? X would be replaced by 1 by x. The very first guess. Let's do that. Let's replace x by 1 by x. If I do that, this would be what? A f of 1 by x plus alpha f of x and b 1 by x plus beta x. just like this. Now what to do? Now we just need to add these two equations. Let's do that. If you add these two, what do you get? You have a times f of x plus f of 1 by x plus alpha times f of x plus f of 1 by x. On the right hand side you have similar thing, b x plus 1 by x plus beta x plus 1 by x, right? So here what I can do is, on the right hand side, yes, I can take f of x plus f of 1 by x common, so that inside the bracket a plus alpha will be there. Similarly, on the right hand side, x plus 1 by x is common, inside the bracket b plus beta. So I am actually looking for this whole upon this. Let's just do the shifting, required shifting. So I have b plus beta whole upon a plus alpha as my answer, and it is already given in the question that both this is what 2 and this is what 1. So final answer already discussed is 2. Both methods were very smaller methods, and this question is a love. Alright. The question in front of your screen is from the chapter Statistics. We always accept, each and every year we expect one question from this chapter, at least one question from this chapter, and this chapter is requiring low input from your end and giving you higher output. Yes. So don't leave that chapter, and always think about revising this chapter at the time of your examination. Okay. So the question says we have 10 natural numbers. What are these 10 natural numbers? 1, 1, 1, 1 all the way up to 1, and 1k is also there, right? K is also natural number, right? That means 9 ones and single k. That variance of these 10 numbers is less than 10. Then we need to figure out maximum possible value of k. What is the formula for variance? That you need to know. That's all. Okay. So sigma square. Variance is denoted by standard deviation square, that is sigma square, that is equals to sigma x square by n. What is this? Mean of squares. Yes, mean of squares. You have all the numbers. You square those numbers. Now you have new squared numbers. You need to take mean of those squares. Minus square of mean. So you have those original 10 numbers. You just need to take mean of them. So mean of squares minus square of mean. That all you need to remember. Mean of squares. So you have how many numbers? 1, 1, 1 and all the way up to k. So let's square. So 1 square all the way up to 1 square and k square. So this is what mean of squares. This is squares. Let's take mean out of this. So this is what 9. If you add these 10 numbers, 9 plus k square whole upon 10 minus, this is what square of mean. So you need to calculate mean of this. What would be the mean of this? So 1 plus 1, 9 times would be 9 plus k whole upon 10 is mean. Now this is what? Square of mean. This is nothing but sigma square, and this is less than 10. This is the equation with us. This variance is less than 10. Now we need to decode the value of k so that we can talk about. Okay, so we have 9 plus k square by 10 minus 9 plus k by 10 whole square less than 10. Let's solve this out. Let's get the value of k. Okay, 9 plus k square by 10, this would be what? 81 plus, okay, alright, k square, and then we have plus 18k whole upon 100 less than 10. On further solving and taking LCM and all, 10 multiply 9 plus k square minus of 81 plus k square plus 18k, and we have less than 1000. Right? Let's just solve this. So we have with us 10k square, 9k square, isn't it? And we have minus 18k, and then we have 90 minus 81, which is what? 9 again. This is less than 1000. Right? If I take 9 common, then what do I have? 9k square minus 2k plus 1 less than 1000. Right? So we have k minus 1 whole square less than 1000 by 9. If I take square root on the right hand side, I get k minus 1 since k is natural number. So this is 10 root 10 by 3. Now 10 root 10 by 3. The value of root 10 is somewhere around pi, 3 point something. So I'm talking about approximate value. This would be what? 3 point something. So overall this is what? Okay, 1 point something. Isn't it 3 point something by 3 is 1 point something? So this value would be what? 10 point something less than k minus 1, right? And the value of k would be what? Less than 11 point something, right? The value of k is less than 11 point something. So the maximum value of k, if I talk about the maximum value of k, that would be what? Integral value. That would be what? K is equals to 11. So final answer of this particular question is nothing but 11. Got it? The question in front of your screen is from the chapter 3D Geometry, which says we have a lambda, which is an integer, and if the shortest distance between these two lines is given by root 7 by 2 root 2, then we need to figure out the value of modulus lambda. So the whole question is based on one formula, which is nothing but the shortest distance between two lines. Isn't it? So once I know the formula, the question would be extremely easy for me. Let's just start. Let's first actually convert these two equations in standard form. By standard form, I mean that I'm able to guess the point on these two lines each and direction ratios of these two lines, because we have to put these two things in our formula. Let's begin. X minus lambda by 1, that is equal to, now how to convert in standard form. What I want is, I want to make the coefficient of x, y and z 1, right? So what I'll be doing is, I'll be dividing the whole equation by 2. So x minus lambda by 2, that is equal to y minus 1 by 2 by 1, and here we have z by minus 1, right? Dividing by 2. Okay, so I can clearly see that this is the equation in standard form. Now point on this line would be what? Lambda half and 0. Yes, lambda half and 0. This is how we calculate point on any line in 3D form, right? And next we have this line. So already xyz coefficient is 1, so we don't need to think about this. This is the line and the point, clear cut, 0 minus 2 lambda, and lambda is the point on second line. Isn't it? Okay, cool. Now what about the formula? Distance between two skew lines, or the shortest distance between two lines, is given by this. What is this? Let us understand. So here A1 and A2 are the two vectors formed by these 2 points. Position vector of point 1 and point 2 respectively. A1 and A2. So here this is A2 minus A1 or A1 minus A2. Anyway, we have a modulus involved, right? So this is A2 minus A1. Next vector we have B1 and B2. What is B1? B1 is a vector formed by direction ratios of line 1. B2 is vector formed by direction ratios of line 2. And of course in the denominator we have magnitude of B1 cross B2, right? Let's just put value straight away. So here we have, in the numerator we have a determinant A2 minus A1, that is lambda minus 0 lambda. Then we have half minus 2 lambda plus 2 lambda, and we have minus lambda, 0 minus lambda, right? So this is sorted. A2 minus A1 is sorted. What about B1? B1 is 2, 1 minus 1. And what about B2? It is 1, 1 and 1. This is numerator. What about denominator? Right, so let me mark it as numerator. Numerator of this expression. Denominator is nothing but B1 cross B2. So here we have I cap, J cap, K cap, and we have 2, 1 minus 1. 1, 1, 1. That's all. Let's make numerator by denominator properly. This is what you get. Now let's just solve it. So let's expand this numerator determinant. So we have lambda times 1 plus 1, that is 2. Then we have minus of half plus 2 lambda, right? Inside the bracket I have 2 plus 1. Is it? Yes, that is 3. And we have, last but not the least, lambda times. So here we have 3 and plus lambda times. Okay, minus lambda times we have 2 minus 1, that is 1. Right, this is what? Numerator. Okay, cool. What about the denominator? So we need to actually find out the magnitude of this vector. So this would be what? 1 plus 1, that is 2 I cap. And then we have minus j cap, and we have 2 plus 1, 3. Right? And then we have 2 minus 1, that is okay, plus k cap. Magnitude of this would be what? Square root of 4 plus 9 plus 1. This is square root of 14. So this is square root of 14. Right? Let's just solve this. If you solve this, you actually get minus 5 lambda minus 3 by 2 in the numerator, and you have root 14 in the denominator. Okay? Alright, and this value would be equal to, given this value would be equal to root 7 by 2 root 2. Now we just need to solve it to get the value of lambda. Let's do that. So, okay, let's talk about this. 5 lambda plus 3 by 2. Modulus of this value is actually equal to root 14, which is root 7 root 2. And we have another root 7 by 2 root 2. Right? So, root 2 gone, root 7 would be 7. So, 7 by 2. RHS is 7 by 2. Or plus minus 7 by 2, because I am removing the modulus. Right? If you solve this, if you take plus sign, minus sign, what would you get? So actually over here, let's cross multiply 2. So 10 lambda plus 3 is equals to plus minus 7. Yes, 10 lambda plus 3 is equals to plus minus 7. So 10 lambda plus 3 is equals to 7 means lambda would be equal to a fraction. Lambda is an integer, so I'm not taking plus sign. Let's take minus sign this time. So here we have lambda is equals to minus 1. Yes, lambda is minus 1. That is an integer. I am interested in the value of modulus lambda. And the answer to this particular question is 1. Just a pure formula based question. Got it? The question in front of your screen is from the chapter Complex Numbers, and from two chapters actually, Complex Numbers and Sequence and Series, hybrid question involving two concepts. Right, these days these questions are trending because in one question they can test the concept behind two chapters. So let's start. Here we have this as k. Right, as per the question, this expression is equal to k, which involves so many complex numbers, and we have n. N is equals to greatest integer function of modulus k. Okay, alright. Here we need to actually evaluate the value of this expression, which is equals to k. Once I have k, I'll put the k over here. So k is sorted. If k is sorted, then n is sorted. And in this question, we need to figure out the value of this. Once n is sorted, we need to put the value of n over here. We need to determine the value of this series. Two parts. The question is whole about two parts. First, let's solve k and then figure out the value of n. Eventually solve the series involving summation. Okay, so let's talk about one by one. So this is minus 1 plus iota root 3, a complex number, x plus iota y. Right, so what I'll be doing is I'll be converting this into polar form. What is polar form for any complex number? So actually x plus iota y is equals to r e raised to power iota theta or r cis theta. Three forms of complex number. Every and any time we can convert within each other. All these forms, interconvertible forms. Right now what I'm looking for is conversion of this form to this. Here r is nothing but modulus of the complex number. How to calculate modulus? R is square root of x square plus y square. Right? So here x is minus 1, y is root 3. Right? So 1 square plus root 3 square is 4. So this would be what? 1 plus 3. That is equals to r would be 2. So this is 2 e raised to power iota and that angle involved, and we have a power 21. Similarly, this also will have modulus 2 e raised to power iota and then power 21, and this denominator of first term would be what? Okay, this time if you calculate the modulus, what would you get? Root 2 e raised to power iota angle. I'll be calculating angle. Angle by angle over here means argument. Here theta is the argument of this complex number. Let's leave that space for this 24, and we have root 2 e raised to power iota argument of this complex number. Right? So now we just need to know about argument of all four complex number. How to do that? For this, again, we have to figure out in complex plane the position of this complex number, all these four complex numbers. So let's just figure out. Let's talk about -1 plus iota root 3, x plus iota y, -1 plus iota root 3. X is negative, y is positive. That means second quadrant, right? And theta would be what? Tan inverse, or let me write it this way. Tan theta is equals to y by x. Right, here y is what? Root 3, x is -1. Let's talk about the positive value. Root 3 by 1, because angle we are taking care with the quadrant wise. Tan theta root 3, angle would be pi by 3 in second quadrant. If we need to figure out this angle, right, this is pi by 3. So pi minus pi by 3 would be the argument of this. Pi minus pi by 3 is 2 pi by 3. Argument of first complex number. Argument of second one would be what? Okay, this 1 plus iota root 3, first quadrant, angle would be what? Pi by 3, just that. Right? What about this? Again, 1 plus iota, that means 1 comma 1 is the point in first quadrant. The moment you put y and x, 1 by 1 is equals to tan theta. Theta would be pi by 4. Let's talk about this. X is positive, y is negative. Fourth quadrant, again x and y both are 1 and -1. We are talking about the positive value. So that is, in fourth quadrant, pi by 4 would be what? Minus pi by 4. Right? This is it. Now we just need to solve it. Let's do that. 2 raised to power 21, 2 raised to power 21 common. Right? So here we are left with e raised to power iota, and then we have 7 to the 14 pi, and here we have again 7, so e raised to power 7 pi iota, right? And then in here root 2 raised to power 24 is common, which is 2 raised to power what? This is 2 raised to power 21, this is 2 raised to power 12, right? And in this denominator, what do I have? E raised to power, so this is 6 iota minus 6 pi, and in here we have e raised to power 6 pi iota, right? This is the final value. Let's solve it further. So we have 2 raised to power 9, right? And we have this 14 pi plus 6 pi in the numerator, e raised to power iota 20 pi, and then we have plus e raised to power iota pi, right? This is it. E raised to power iota theta. E raised to power iota theta is nothing but cis theta. What is cis theta? Cos theta plus iota sin theta. Let's just put the value 2 raised to power 9 cos theta plus iota sin theta. What is this? This is 0. Cos 20 pi is 1. So this is 2 raised to power 9. This value is 2 raised to power 9. And what about e raised to power iota pi? Cos pi plus iota sin pi. Sin pi is 0. Cos pi is -1. So this is -1. This is +1. 2 raised to power 9. We have 1 minus 1, that is equals to 0. The value of k is nothing but 0. And the value of n, which is GIF of modulus 0, is what? N is equals to 0. So now we have very own n equals to 0. And we need to figure out this series. The moment I put n equals to 0, our series will be what? This. N would be gone. That's it. 0 to 5, both the terms. Okay, alright. Let's just expand first sigma. The moment I put 0, I get 5 square, then plus 4 square, and then, okay, 6 square, and then all the way up to 10 square, minus this. So 5 plus 6 plus 7, all the way up to 10. Right? What I need to do is complete the series. So I need to add 1 square plus 2 square plus 3 square plus 4 square, and I need to subtract it as well. Same with this. If I do that, I'll get this. 1 to 10, right? 1 square, 2 square up to 10 square, and subtraction of this. Similarly, 1 plus 2 plus 3 up to 10, subtraction of this. Let's just apply formula quickly. So this would be what? Sigma n square is n plus 1 to n plus 1 by 6. Sigma n square, right? Let's put the formula. So we have up to 10. So 10 multiply 11 multiply 21 by 6. The value would be 385. So this would be what? 385, right? Subtraction of this, again same formula, but n would be what? 4. So this time I'll be applying n equals to 4. 4 multiply 5 multiply 4 to the 8 plus 1, 9 by 6. So I have, if you solve it, you will have, okay, 30. So this would be minus 30. Okay, and this is n plus 1 by 2. 10 into 11 by 2, that is what? 55, minus this is what? 4 multiply 5 by 2, that is what? 10. So we have 55 minus 10 with us, that is 45, and we have 355. 355 minus 45 is what? 310. So finally the calculation, you can easily do this calculation, not a very tough calculation. So here we have 310 as our answer, which is 310. Alright. The question in front of your screen is from the chapter circles, and moreover the topic is locus. We need to figure out locus of a point. Let's read out over here what is given. Let a point P whose distance from point 5, 0 is thrice the distance from the point minus 5, 0. Alright, that means if I mark it A and this as B, that means we have PA is equals to 3PB. That's how we tackle the locus question. We interpret the geometrical condition and convert into mathematical expression. That's all. Alright, next we have, if the locus of the point P is a circle of radius r, then we need to figure out the value of 4r square. In short, we need to figure out the locus of point P. Let us assume point P as h, k. Right, let's apply the distance formula over here. So point P is h, k, and PA is equals to 3PB. A and B are given. Let's square both the sides. PA square equals to PB square. Right. Now let's apply the distance formula. H minus 5 whole square plus k square, that is equal to h plus 5 whole square plus k square. Right. And of course we have 9. PA square is equals to 9PB square, isn't it? Okay. Cool. H square plus 25 minus 10h plus k square, that is equal to 9h square plus 25 multiply 9 plus 90h plus 9k square. Let's just shift everything towards the right hand side. What do I have? 8h square plus 8k square. Alright. We have 100h with us, and we have last 25 multiply 9 minus 25 would be 25 multiply 8, that is equals to 0. We are looking for radius of this particular circle. See, this is a circle. Let's divide the whole equation by 8 and replace h by x and y by k by y. So we have x square plus y square plus 100 by 8 is 25 by 2x plus we have 25 equals to 0. Let's just calculate radius. So radius square would be equal to minus 25 by 4 whole square minus 25, isn't it? And we need to remove square because we are calculating radius square, right? So here we have 625 minus 25, 625 by 16 minus 25, right? Let's multiply 4 in this. If I do that, what do I get? 4r square equal to 625 by 4 minus 100. Right, if you solve it, what would you get? You get actually 225 by 4. If you divide 225 by 4, what would you get? Exactly 56.25. Finally, you have 56.25 as your answer. Alright. Next, we have a straightforward question from the chapter Sequence and Series, which says, the sum of 4 terms of geometric progression is 65 by 12 and the sum of their respective reciprocals is 65 by 18. It is further given that if the product of first 3 terms of GP is 1, then we are interested in the third term. Actually, we are interested in alpha and we need to figure out the value of 2 alpha. Here alpha is the third term. Alright, let's begin. This is the given information. Let's start. So sum of first 4 terms of a GP is 65 by 12. Let us assume the terms are A. First term is A. Common ratio is R. Then second term is AR. Then AR square. Then AR cube. Right. So sum of these four terms, a plus ar square plus ar cube equals to 65 by 12. If I take a common, what do I have? I have this first equation, right? Okay. Sum of their respective reciprocals, that means 1 by a plus 1 by ar plus 1 by ar square plus 1 by ar cube equals to 65 by 18. In here we are taking 1 by a common. So we have 1 by a with us. This is second. Right? Let's take LCM of the second first. Right? 1 by a, then we have r cube with us. Then we have r cube plus r square plus r plus 1. This is equals to 65 by 18. This is second equation. Right? Now can you clearly see equation number 1 and equation number 2 has this in common? Let's divide these two. If I do that, what do I get? A by, okay, we have actually a square with us. This term will get cancelled out. Then we have r cube, that is equal to what? 65 by 12 by 65 by 18. 65 gone. 3 4s are 12. 3 6 are 18. And then we have this 2 and 3. So a square r cube. A square r cube, we are having 3 by 2. A square r cube value is equals to 3 by 2. Okay, we are looking for third term, right? Third term means ar square. We are looking for this value. For this, we need to know a and r. Okay, one more information is given in the question, which is product of first three terms, ar square. Product of these three terms is equal to 1. If you multiply these three numbers, what do you get? A cube r cube, this is equal to 1. These two are the equation from which you need to get the value of a and r. How to do that? Simple, we just need to divide the fourth equation by third equation. 4 by 3. If you do that, you get a cube r cube and a square r cube, that is equals to 1 upon 3 by 2. That is equals to 2 by 3. So a square and a cube, 1a will be left, r cube completely gone. The value of a you're getting is 2 by 3. Alright, the value of a you're getting is 2 by 3. Let's put the value of a over here. So you get 2 by 3 whole square. R cube equals to 3 by 2. Isn't it? In here you're getting r cube equals to actually 3 by 2 whole cube. Right? So r equals to 3 by 2. A is 2 by 3. R is 3 by 2. And we are looking for alpha, which is third term. Third term is what? AR square. Let's just put the value. The question is done. Almost done. So we have 2 by 3 multiply 3 by 2 whole square. Right? So this is nothing but 3 by 2. Alright. The value of alpha is 3 by 2. So the value of 2 alpha which we are looking for is nothing but 3. Alright. So the value of 2 alpha is 3. And hence the answer of this particular question is a cute little 3. Alright.